AC node is the pacemaker of the heart. How is the action potential of AC node conducted to both ventricles? There are so many chylomyocytes. Why do they contract at the same time? Why do ventricles contract after atrial contraction? To settle all these questions, we'll learn the conductivity of myocardium. Conductivity is the characteristic of conducting action potential. The principle is the same as that of neurons and the skeletal muscles. Local current from the excited area depolarizes the unexcited area to threshold potential to trigger a new action potential. The conductivity of myocardium is closely related to the structure. There are a large amount of gap junctions between myocardial cells. The electrical change of one cell can be quickly transmitted to the surrounding through gap junctions. All the myocardium can excite and contract at the same time, just like one cell, so it's called functional sensation. The atrial and ventricle are separated by connective tissue. Therefore, the atrium and the ventricle become a functional unit, respectively. AC node is the pacemaker of the heart. Its action potential can be directly transmitted to both atria. The myocytes between AC node and the AV junction are arrayed orderly, like cones, being called atrial cone. The resistance of atrial cone is small due to arraying orderly, and the conducting is fast. So we call it preferable route. The action potential is transmitted from AC node to AV junction through preferable route. Two bundle heads, left and right branches, and to the Purkinje fiber. Purkinje fiber threading under the endocardium can quickly transmit the excitement to ventricles, so both ventricles excite and contract at the same time. Among the special conducting system, Purkinje fiber has the fastest conducting speed, 4 meters per second. The conducting at AV junction is the slowest, 0.02 meters per second. It takes a long time, about 0.1 second, for action potential passing through AV junction. We called it AV delay. In normal conditions, atrial systole is also 0.1 second. So the ventricle just contracts after atrial contraction, which is beneficial for the filling and the ejection of ventricles. 3 factors affecting myocardial conductivity. The first is anatomical factors. The conducting speed is closely related to the cell size and the number of gap junctions. The cell is bigger or gap junction is more, the conducting is faster. Nodal cells in AV junction is the smallest, and the gap junctions are less, so the conducting is the slowest. The second is physiological factors, including depolarization speed in phase 0 and the amplitude of the action potential. Depolarization is faster, or the amplitude is bigger, the local current is faster. So the conducting of action potential is faster. Purkinje fiber is fast response cell. The depolarization amplitude is 120 millivolts, and the potential difference between the excited and the unexcited area is bigger. The local current formed fast. So the conducting of Purkinje fiber is the fastest. The nodal cells are slow response cells. The depolarization amplitude is only 70 millivolts, so the conducting is slower. The third is excitability of adjacent part. Only when the adjacent excitability is normal, action potential can be transmitted through. If the adjacent membrane is in the refractory period, action potential can't be transmitted through. This is also the reason that action potential is transmitted from up to down, but cannot transmit it back. If action potential from SA node can't be conducted to the whole heart, we call it conduction block. The most common block site is AV junction, being called AV block. Let's do a summary. Action potential from SA node excites both atria at the same time. Is transmitted along the special conducting system. The conducting in Purkinje fiber is the fastest. In the AV junction, it's the slowest. Ventricle begin to contract after atrial contraction due to AV delay, which is beneficial for the filling and the ejection of ventricles. That's all for this class. See you.